Thank you very much. I feel like we saved the best talks for last. Just kind of too bad because I'm really tired. But I really enjoyed all of them nonetheless. Questions? Go ahead, Julia.
So my question is for the fuzzing talk. Specifically, I'm wondering, are the hooks still in QEMU, or is it just compiled out in binary builds? And additionally, what performance impact did those hooks have?
Okay, I'll just talk loudly. Our hooks the stuff that's in QEMU right now has like very limited performance impact because it's leveraging the testing framework that's already there. And then all of the additional hooks that were added basically are configured out for standard system builds. So there's no performance impact for regular systems.
So it's more like a debugging build at that point to do the fuzzing tests.
Sure, yeah, you can say that.
Okay, thank you.
Yep.
Any other questions? John Goodhue.
I'll give it a try. For the streaming, have you considered trying to get the best of both worlds by keeping it separate while you're prototyping and developing, and then creating some automated way of mashing the two elements together, the model and the streaming environment?
Sorry, so is the talk about the model serving, or which
You
part?
talked about the trade-off between mashing the model and the streaming element together, or keeping them separate. One's more flexible, the other's more performant.
Right.
Could you create something that lets you develop and prototype in one environment, and then in an automated way, so you have something correct at the end, match the two together?
Right. So yes, I'm not talking about doing the training inside the stream processor, so that still is happening outside, right? So you need a way to update the model then when it's time to update it. So let's say once per day or every few hours. So in any case, the training will happen outside. What I was talking about is more the question of how to use the model from inside the stream processor, right? And there, you could either store it in streaming state, in which case it's integrated with the fault tolerance capabilities and the state management capabilities of the system, or you could store it outside, in which case you have all the model serving capabilities, so you have the versioning and you can do ensembles and all the cool things that ML ops systems do, but then you have to pay the RPC latency every time you need to classify something. And if you have millions of events per second coming in, then you don't want to pay that. So you could imagine caching part of it in memory, right? I don't know if that's what you're talking about.
I was looking for a mode bit where you could do either the most performant thing or the most flexible thing.
Right. So the most performant thing in most cases is keeping it inside the stream processor, right? And the most flexible thing is keeping it outside. It's true. Unless we build a state store that has the capabilities of model server stores inside the stream processor. Yeah. So this is where this is heading. Thank you.
Any other questions for our speakers?
Yeah, so for all of you, basically, do you think that your code could run in an FPGA? If it was like attached, would it be better? I mean, there are like streaming FPGA companies, and for all of you, like the analytics, if you just threw the data over to the FPGA, would that be better or worse, or what are your opinions? And that's for everybody.
I haven't thought about it. I don't know. I don't know if anybody's doing fuzzing inside FPGAs. They probably are, but I'm not.
Maybe like you could generate all the numbers and all that stuff from
Yeah,
the
maybe.
FPGA, and, it'd be no load on the CPU.
Yeah,
Same with like all of you, like looking at all the journaling and all that kind of stuff. If you just threw it into an FPGA, you'd be analyzing at the same time as running,
Yeah, I think my system would probably be running on a different CPU. So instead of running on a different CPU, it would be running on a different FPGA, and I don't think it would matter that much. As long, if you have a spare FPGA versus a spare node, you could do both either.
I think we're losing our, sorry. I think we're losing our audience and stuff, which I don't blame them at all for this time. So first, thank you to everybody. Do we want to have the session chairs or for the deep dive? Actually, it was only you, right? It was only storage one that was? Okay. All right, so should we get, okay. Do you want to kind of grab them? Any, I guess while we're waiting, like what did people think of this? Was this useful and yell at us? I haven't had anybody yell at me about what we should change next time around. Yeah, I strongly agree with this. Can I second this? Dark beers. Yeah. Okay.
But I had a good time here. I learned a lot. I'm an FPGA expert, so that one of my weak points is basically cloud stuff, how to apply all my 30 years of knowledge to the cloud. So for me, this was really eye-opening, and I learned a lot.
Cool. We're waiting for the buff. Let us know. What? Okay. So,
Okay. Well, so I think is there one more question? Julia, you had a.
I feel like this was built around a subconscious idea to have a giant hallway track. And I think it's actually probably a really good thing, because you actually end up in a situation where people meet each other and get to know each other and talk about other things. I almost feel like this might be one of those cases where both more structure and less structure. Like if there's chaos and paralleled order, but maybe I'm just crazy.
is that what we did, or is that what we should do?
It feels like there was lots of order, and there's actually been a really good schedule in terms of we've kept very close to it, but I also think that there's a place and time for less of that, if that makes sense. And I think that's kind of what ended up happening is people started drifting outwards and kind of having their own hallway track discussions outside, and getting them crowded back into the room is pretty hard. I think the way Birds of Feather was done was actually kind of like conflicting chaos, if that makes sense, because you actually end up in a situation where because of how late things were getting scheduled, I don't know about everyone else, but when I'm traveling or in a conference, I don't look at my email, I don't try and look at Google Docs, I try and actually listen and engage. So it's like, oh, I didn't realize there was this other thing I need to go look at.
Well, thanks very much, speakers. We really appreciate it. Great talks.